channel, a communication channel receives independent pulse at the rate of 12 pulse per microsecond. The probability of transmission error is 0.001 for each microsecond. Compute the probabilities of first one, no error during a microsecond. Second one error per microsecond. One error per microsecond. At least one error per microsecond. Fourth one, two errors. Fifth one, at most two errors. Now, first we have to find out the mean value, that is m. So whatever they have given, that we have to write p is equal to 0.001. That is, we can write probability of transmission error. Next, n they have given 12. N value they have given 12. So m is equal to np, that is equal to 12 into 0.001. Yes, what 0.012. Next, probability function p of x is equal to e power minus m power x divided by x factorial. So e power minus 0.012 into 0.012 whole power x divided by x factorial, 0.9880. This is the value. Next, here we can come back for the first sub question. No error means p of x is equal to 0. So 0.9880 into 1 is 0.9880. Second one error. So p of x is equal to 1. 0.9880 into 0.012 whole power 1. 0.0118. Next, third one, at least one error. So P of at least one error. So at least one error means 1 minus of P of 0. That is equal to 1 minus e power minus 0.012. We all know P of 0 value is 0.9880. That is equal to, next I write here continuation. Fourth one, two errors. P of 2. So here 0.9880 into 0.012 whole square divided by 2 factorial value is 2. 4 times of 0, 7. Next, last one, probability of at most 2 errors. At most 2 errors. So at most 2 errors means P of 0 plus P of 1 plus P of 2. Here in all the term we can write 0.9880 as a common term. So first one, 0 means 1 plus 0.012 divided by 1 plus 0.012 whole square divided by 2. 0.9999. Approximation we can write it as a 1. Approximation value we can write it as a 1. Screw making machine, a certain screw making machine produces on average 2 defective out of 100. 2 defective out of 100 and packs them in boxes of 500. Packs them in boxes of 500. Find the probability. Find the probability that the box contains first one 3 defective, second one at least 1 defective, third one between 2 and 4 defective, between 2 and 4 defective. So here we have to find out the value of P. Here 2 defective out of 100. So here we can write P is equal to 2 by 100. So we get 0.02 and packs them in box of 500. So boxes of 500 means n is equal to 500. M is equal to n into P. So 500 into 0.02. What is 10? Now write the probability function e power m power x divided by x factorial. So e power minus 10 power x divided by x factorial. Now here first one they asked 3 defective. So P of 3. So here I forgot to write 10 power x divided by x factorial. So 0.00045 10 power 3 divided by 3 factorial. 000045 4 zeros 7
7.
5. Okay. At least one defective. At least one defective means here P of x greater than or equal to 1. So 1 minus P of 0. So 1 minus here P of 0 means e power minus 10. So 1 minus 0.0000045. 999 approximate we can write 1. Between 2 and 4 means P of 2 less than x less than or equal to 4. So between 2 and 4 means P of 2 plus P of 3 plus P of 4. That is equal to here P of 2 means here I write 0.000045 outside. So P of 2 means 10 square divided by 2 factorial is 2. Next 10 cube divided by 3 factorial is 6. Then 10 power 4 divided by 4 factorial is 24. 300 misprints. Question paper problem. Suppose 300 misprints are randomly distributed throughout a book throughout a book of 500 pages throughout a book of 500 pages. Find the probability find the probability that a given page contains first one exactly 3 misprints, exactly 3 misprints, second one less than 3 misprints, and third one 4 or more 4 or more misprints, 4 or more misprints. So here we have to find out m. So what we have to write, number of misprints divided by number of pages. Number of misprints divided by number of pages. So here we get misprints is 300 divided by pages is 500. What is the answer? Next, P of x is equal to e power m minus m power x divided by x factorial. So e power minus 0.6 m power x, sorry, here also 0.6 whole power x divided by x factorial. 0.6 whole power x divided by x factorial, write as it is. First one, 3 misprints. So P of 3, 0.5488 into 0.6 whole power 3 divided by 3 factorial. Second one, less than 3 misprints, less than 3 misprints. So here x is less than 3. So P of 0, P of 1, P of 2. So P of means 0.5488 I will write outside as a common term. Here first one 1, 0.6 divided by 1, 0.6 whole square divided by 2 factorial. 6, 8. Last one, here 4 or more misprints. 4 or more misprints. So here 1 minus of P of 0 plus P of 1, P of 2 plus P of 3. 4 or more misprints. So I just write here 0.5488 as a common 1 minus here first one 1.6 0.6 whole square divided by 2 again 0.6 whole cube divided by 3 factorial 0.00337 continuous probability distribution. Here also conditions it should satisfy. First condition is f of x greater than or equal to 0. Second condition is integral limit varies from minus infinity to infinity. F of x into dx is equal to 1. These two conditions should satisfy for the continuous probability equation, or we can call this one as a probability density function. Probability density function. Both are same. Here also we study about mean and variance. Mean formula is minus infinity to infinity x into f of x into dx. Next, variance. Variance means sigma square. Here minus infinity to infinity x minus mu whole square into f of x into dx. Just note down the formulas. Next comes here exponential distribution. Exponential distribution. Definition you just see because sometimes they ask the definition of exponential also. This is the definition. F of x is equal to alpha e power minus alpha x for x is greater than 0. 0 otherwise where alpha is greater than 0. This is the definition of the exponential. Now we see some mean formula of exponential, that is 1 by alpha. Next, variance. Variance is V, that is sigma square. We can also call this one here 1 by alpha square. Next, standard deviation. Root of variance, that is sigma is equal to 1 by alpha. These are the three mean, variance and standard deviation. There is a different formula for continuous probability distribution and exponential distribution. Let us see first problem in the probability density function or continuous probability density function. Yes, find which of the following functions which of the following functions is a probability density function or continuous probability distribution. Both are same. Density function. So let us see the first problem. f1 of x is equal to 2x. Here 0 less than x less than 1. 0 otherwise. So first we have to start the problem with the condition. Conditions for a probability density function, we can write p dot d dot f. Are first condition f of x greater than or equal to 0, and second is integral limit minus infinity to infinity f of x dx is equal to 1. So here clearly f of x is greater than or equal to 0. Next, we have to check for second condition. Minus infinity to infinity. Here in place of f of x, they have given f1 of x. So here write f1 of x into dx is equal to, limit varies from 0 to 1. f1 of x into dx. So 0 to 1 limit we have 2x into dx. Integration of x is 2, I will write x square by 2. 2 will get cancelled. Limit varies from 0 to 1. So 1 minus 0, that is 1. Therefore, f1 of x is a probability density function. F is equal to, here 2x, limit minus 1 less than x less than 1, 0 otherwise. So here we have to rewrite the above question. So 2x, first I will write minus 1 less than x less than 0. Second one again 0 less than x less than 1. Here I defined the limit between minus 1 to 1. First one I have taken minus 1 to 0 and next 0 to 1. Last 0 I will write as it is. So in here minus 1 less than x less than 0, f2 of x is equal to 2x. So if you define, it will come is less than 0. Is less than 0. How it will become less than 0? Here minus 1 to 0, 2x into dx. Integration will be x square. 2 will get cancelled. So we get x square minus 1 to 0. So 0 minus I will write minus 1 whole square. So minus 1 is less than 0. So our condition, what is our condition? F of x should be greater than or equal to 0. So first one, it will not satisfy. Next, second one. Second one is minus infinity to infinity. f2 of x into dx. Here also second one. So here minus infinity to infinity means we can go with the minus 1 to 1 f2 of x into dx. That is equal to minus 1 to 1 2x into dx. Here again 2x square by 2. 2 will get cancelled, minus 1 to 1. So 1 minus of minus 1 whole square, that is equal to 0. That is equal to 0. So here both the conditions they are not satisfied. Suppose if you want to do individually, this one, second one, individually you have to do means limit 0 to 1 2x into dx. So x square 0 to 1, here we get 1, but we are taking the limit minus 1 to 1 f2 of x into dx, that is first one 0 minus 1 to 0 f2 of x into dx plus second one 0 to 1 f2 of x into dx. So first one we got minus 1, for the second one 1. So 0. So what we have to write? Both, if you are taking individually, both the conditions are not satisfied. Both the conditions are not satisfied. Therefore, f2 of x is not a PDF. Both the condition means first condition f of x must be greater than 0 and second one minus infinity f of x dx should be equal to 1. If it is a probability density function, both the conditions must be satisfied. Therefore, f2 of x is not a PDF.